Welcome to the 14th lecture on probability and statistics. And in this lecture, we will study measure of spread. Measure of spread. Before this, we have studied measure of mean. And in that, we studied mean, median. We studied measure of center, in fact. And in measure of center, we studied mean, median, and mode, three measures. And we studied them in detail in the last couple of lectures. Today we'll study measure of spread. Why do we need measure of spread when we have measure of mean? We require measure of spread because we may have data where histogram is something like this. But we may have another data for which the histogram is somewhat like this. These two data have the same mean. Mean means the same center, the same measure of center. The center is the same, the mean is the same, but they have, but they look different from each other. So this means that only the mean or the center or the measure of center is not a good measure alone. The measure of center is not a good measure alone. We need more we need more kind of measures. For this reason, we study one other type of measure, that is the measure of spread. So now in this lecture, or generally in statistics, we study two types of measures: measure of center and measure of spread. So we study two type of measures: measure of center like median, mode, mean, and measure of spread that we will study in this lecture onwards. So the range is, we'll study two types of measures of spread. In this lecture, we will study two measures of spread. Namely, number one is range, number two is variance. The measure range was studied by us in chapter number one, right? In chapter number one, we studied range. Range is the difference between the max and the mean value, max minus mean. It's simple. Variance is a kind of more complex measure where we first compute the mean on the given data. This is the sample mean. We studied sample mean in our last lecture, or in lecture, one lecture before, maybe, or two lectures. Xi, we compute a summation. We know the sign summation. We studied when we were studying mean. Xi minus the mean of x divided by n minus 1, where n is the total number of measurements or total number of observations in our data set. So this is a more complex or a better measure to or a measure or a better measure of spread. Right. Range is a simpler measure. It's a relatively simple but has some disadvantages. Therefore, we normally don't use it. What is the disadvantage of using range as a measure of spread? Right, this example illustrates the reason why we shouldn't use range as a measure of spread. Why? Because these are two histograms, two data sets. Histogram 1 for data 1, histogram 2. This means this histogram was drawn for data 2. We see they have the same range, the same max minus min, the same max minus min, but they have different spread or different shapes. So this means range is not a good measure because two histograms may have different shapes, they have different spread, but they have same range. So it's not a true measure of spread. So range is a measure, but it's not a good measure. Right. So now the question is that what is a good measure? This one, variance. Variance is a good measure. Let's see how. First, we will compute. First, we will apply the formula for variance on a data set. Right. So the formula is this summation. Let me write it once again on top of the board. Variance is a better measure of spread and is represented as either s squared or or sigma squared. We have two letters to represent variance. When we use it for sample, we use this letter s squared. When we use it for population, we use this Greek letter sigma squared. So we work on, in the example to come, we work on sample, on a small sample of data where we have given numbers 5, 7, 1 to 4. 5, 7, 1, 2, and 4. Right. So we are going to compute. We are going to compute variance on this, and we know the formula. It is, so since we are working with sample, the formula is s squared is summation of I from 1 to the number of observations or number of measurements in this data 1, 2, 3, 4, 5 xi minus mean of x squared over n minus 1. N minus 1 means 5 minus 1, which is 4 in this case because n is 5. So for this data, n is 5. So n minus 1 is 4. So to compute variance on this data set, we need one more quantity. That is the mean of x, the sample mean. How would you do that? The sample mean is, the sample mean would be, we know that it's a summation from 1 to n, where n is 5, xi divided by n. It should be divided by n. So n is 5 in this case. So we add all these 5 plus 7 plus 1 plus 2 plus 4 over 5. So the sample mean comes out to be 3.8. This is 3.8. So how would you compute the variance then? How would you compute the variance then? Because this is a summation over this difference squared. Right. So we have xi's, we have xi minus x mean, xi minus x mean squared. So we have to compute these measures for all data points in in our data set. This one for all observations, for all measurements. The first measurement is 5. We need to compute 5 minus the mean, which is 5 minus 3.8. 5 minus 3.8 squared. Should have some answer. This is 1.2, this is 1.44. The next data point is 7, for which this is 7 minus 3.8. This is 7 minus 3.8 squared. 10.24. The next data point is 1, for which this is minus 2.8, because 1 minus 3.8 is minus 2.8. Minus 2.8 squared is 7.84. For 2, this is minus 1.8 squared, 3.24. And for 4, this is O2, O.2, O.04. So we have sum of x 19, sum of these differences is 0, and sum of differences squared is 22.8. So now we can use either this or this as a measure of spread. What if we use this difference not squared, without squaring? If we use this difference as a measure of spread, what is the disadvantage then? Of course, it comes out to be 0. It always comes out to be 0. So 0 divided by the total number of observations, or total number of observations minus 1, would produce a 0. It will always produce a 0. Another way is, it can be to neglect these negative signs and all these up, and then divide by n. That is also a measure, but we will see that squaring gives us a better measurement, due to one more reason that will be obvious as we proceed in this course. Right. So how would you proceed? How would you compute s squared then? Summation squared, we have sum all this, gives us 22.8. This sum operation performed on all these data points is actually the implementation of this summation sign, right? X1 minus x bar squared plus x2 minus x bar squared up to x5 gives us 22.8 divided by n minus 1, 4. And the spread is, what is the spread? 5.7. So it's a good measure. 5.7. So we will use variance. Variance is a very widely used. Variance is a widely used measure of spread in statistics. This is a very widely used measure of spread. Right. One last thing before we conclude this lecture is another term that we use to represent the spread, and that is standard deviation. We use two letters to represent standard deviation. Either we use S or we use the letter sigma. For sample, this is S like we have worked with in this example, and for population, this is sigma. If this is S computed for sample, this is the positive square root of the variance of sample. And if it is for population, this is positive square root. This is positive square root of the variance computed for population. Right. And if we compute S for this example, S would be, for this example, S would be the square root of 5.7 gives us 3 point something, 2.39. 2.39 is the standard deviation. We also call it SD, standard deviation, SD. Right, that's all for this lecture. But in our next lecture, we will use a formula to compute. We will use a formula, in fact, we will derive a formula to compute variance efficiently on a given data. We have computed variance but with a technique involving a table. So let's see if we can compute this using a pattern and without computing mean. Without computing mean, if we could, we will see that if we can use a formula that we can use to compute variance on a given data, on a given sample, without computing the arithmetic mean or the mean first. We'll do that in our next lecture. Thank you.